So what we have now is a data set on Excel, and we have the variables that we're interested in. I'm simply going to click on the lines right here so that I can actually read these two. So minutes exercised and days happy are the variables that I'm interested in. I'm going to pull them out of this sheet, and I'm going to copy them into a new worksheet. And so now they are here, nice and sitting all by themselves. And we could simply click on data, say I want to run a correlation. Okay, pick the variables that we're interested in, click on labels first, click on OK, and then on this other worksheet what would happen is we would get our output, which suggests that there is a correlation coefficient, or there's a correlation, a moderate correlation between days of happiness during a month period and minutes exercised during a week of 0.51. Now, if we compare that to what we have in our output for SPSS earlier that we ran, we would notice that that correlation is exactly the same, 0.519 and 0.519. But we did a few things on SPSS. We actually corrected the data, and then we ran it with a log transformation for minutes exercise. And we can't necessarily do that on Excel, but there is a technique to determine whether these scores are problematic or not. Now, one thing that you could do very easily is simply say, "Hey, listen, I want to see what my extreme values are," and you can do a conditional formatting here and say, give me the numbers in red that are problematic. Now, because I picked the two variables, let's just go back. For this one here, conditional formatting, so it's going to compare all these numbers, and it'll flag in a color the numbers that are different from the others. This is only a visual inspection. This is not a test. You don't need to learn this if you don't want to, but notice that the dark green is showing the higher end of values, and I could have actually done it opposite, where the dark red would be showing the higher values, and the dark red in this case is showing the lower values within the distribution. That would be one way to kind of decide, okay, is this problematic or not? But we're not interested in doing that because that's simply a visual inspection. We actually standardize these scores and determine if they are larger than 1.96 and then make a decision about them. We'll go through the steps just so that you can learn this, but again, this class is not about SPSS or Excel. It's about statistics, and we use SPSS primarily, but if you don't have SPSS, why not use Excel as well? So we can say, dear Excel, help me make a decision about minutes exercise and whether these values are good or bad. So the first thing I'm going to do is I'm going to click on data, and I'm going to say data analysis, and I'm going to say give me some descriptive statistics for this variable, and give me summary statistics, and I have labels on the first row, and let's go ahead and click on confidence low for the mean, and oh, we're missing the range, which is from this variable, from this cell to the last cell. So we can click on OK, and now we have pretty much the same information that we had earlier. If we look at the mean is 57.89, the standard deviation is 19.95. If we were to pull that up over here and look at the data on the first analysis that we conducted, the mean for minutes exercise was 57.89 and the standard deviation was 19.95. So we have an agreement. Thank you, Excel. Do we have some issues here? Doesn't tell us that we have some issues, but what we can do is we can take this data and we can standardize it now that we have the information that we need. So in reviewing, we have a mean of 57.89, a standard deviation of 19.95. So let's simply say, Excel, standardize these scores for me, and let's take the data from here to here. Very good. Let's go back up there and say our mean is 19.95, and our mean was 57 point something. Let's check 57.89. So let's go 57.89, and you could have actually clicked on that cell if you wanted to. Click comma, 19.95 or something like that. Let's check one more time for the standard deviation. Yes, very good. And let's click on enter. So that's our standardized score for that. We can pull this all the way down, and now we have standardized scores. So the 124 that we had earlier that was problematic on SPSS is showing up as problematic here. This 112 is also problematic. You can see that anything above 100 is pretty much problematic. If you were to put the conditional formatting here, and again, you don't need to do this. I just do this to help me see the data a little bit easier. So let's go there. And so everything that's in red is a problematic variable. Is a problematic case. So we could actually simply delete these in the analyses, but again, I'm just showing you what you can do. For the correlational analyses, all you need to do again is click on data analyses, click on correlation, OK, select the variables that you want in the correlation, and click on OK. And you will find that your correlation is just as in SPSS 0.519. Let's scroll down and look at non-transformed 0.519. And that is correlation using Excel.